So in order for all of this to take place, we start with the spinning of the Earth, but what truly is one of the things that takes place because of this Earth spinning is created due to a variance in temperatures on Earth. And due to this variance in difference in temperatures, it can help to create wind, because the difference in temperatures can help to create a difference in air pressure, talking about whether or not you have high pressure or low pressure based upon what is in a particular air mass. So the true difference between air pressure is what's going to cause winds to actually take place. And what happens is, the greater the difference between the air pressure, the faster the wind is actually going to travel, creating faster moving winds. Air pressure is created because of the unequal heating, like I mentioned prior to this. When you have areas that are cooled and areas that are warmed, and also because of the ocean currents moving away from the equator and moving down from the poles, you're bringing different temperatures that can affect the different types of air masses. And those different air masses will affect, based upon their densities, will also affect the actual pressures. So this unequal heating usually takes place every 30 degrees of latitude. So as you look at the globe and how we separate it, you start with the equator, then 30 degrees north and south, then 60, and then 90 degrees is where the poles, both the North Pole and also the South Pole. So every 30 degrees we tend to find that there is a change in the type of heating that that particular location on Earth receives. So as you see right here, as I just kind of drew this diagram for you, you'll notice that every 30 degrees, you have 30 here, there's the equator, and then you have 30 down here, and farther down 60, and then eventually ending up here at the poles at 90. Every 30 degrees, you tend to have a change in the type of temperatures. And as you can see right here, represented by the shading, polar regions in the blue, the kind of moderate temperatures in the green, getting warm and then exceptionally warm in those particular locations that are red. So just kind of showing how every 30 degrees the actual temperatures are changing throughout the entire on Earth, more or less. So with that having been said, these pressure belts that are created because of these uneven heating that takes place throughout the entire world and on Earth, we start to talk about that term convection. Warm air rising, cold air sinking. So as this warm air rises, it moves towards the poles. So as it's starting to move, it gets farther away from the equator and then starts to cool. And what we've talked about, as air starts to cool, it starts to sink because it's becoming more dense. Colder air, more dense than warm air. And then what happens is at the poles, this cold air sinks, and as it sinks, it starts to move away from the actual poles and starts to warm itself up as it moves closer to the equator. So you start to see this change. You have on one side of an ocean, for example, you have colder moisture, such as an ocean current that's actually getting cooler and cooler the farther it moves away from the actual equator. And then on the other side of the ocean, you have this convection cycle where that cold water is starting to make its way back towards the equator and starting to get warm. The same thing happens with the pressure belts. As the pressure belts move air and air masses away from the equator, they start to get cooler and the air starts to sink. As those pressure belts start to move those air masses from the poles back to the equator, they start to warm up and they start to rise. So in this case, it's a combination to form global winds based upon the changing of our atmospheric temperatures, along with winds being formed, and the Coriolis effect that will eventually cause the global winds that we find here on Earth to actually take place. And the ones that we'll talk more particular about are the polar easterlies, the polar westerlies, and then the trade winds. And within each of those, you're going to find some little interesting nicknames for types of winds that are found in each of those locations. So, as an example, you'll notice that where the equator is located right here, you see that the trade winds are both to the south and also to the north of the equator. And they are from the equator all the way up to 30 degrees north and 30 degrees south. Those are where we find the trade winds. The second one are the westerlies, found between 30 and 60 degrees. And again, westerlies down here, 30 to 60 degrees south. And then the last are the polar easterlies, which are 60 to 90. So looking at this area all the way up to the pole. And again, polar easterlies from here down to the South Pole. So those are an example of where they're located. Let's talk more specifically about the first, polar easterlies. What happens is polar easterlies are from the 60-degree latitude, like I mentioned, all the way up to the poles. And how they're formed is that you get cold air which is sinking, and as this cold air sinks, it creates cool temperatures. And because of this cold air movement, it's what's helping to push and drive the actual easterlies, the wind. And as you notice right here, you can see that they're moving away from the actual equator. And we'll talk more why these things actually move in the direction and why they bend in just a little bit. But this is just to give you a perspective about the way the actual currents move in those particular locations. Westerlies are found between 30 and 60 degree latitude, between the 30 degree north and 60 degree north and the 30 and 60 degrees south latitudes. And what happens here is that you get movements where the poles are moving from west to east carrying moist air, because now what you have is you have these spaces that are taking moisture both from the equator and also back to the equator. So as cold air from the poles is starting to get warmed up, it's starting to gain more moisture because there's more evaporation that's starting to take place and condensation forming. And then the same thing takes place with moisture that's in the air that's moving away from the equator. It's starting to cool, it's starting to condense, and that helps to create condensation and then eventually precipitation. So that's why you have tendency to see a lot of moist air. And again, those locations are right here. And again, we'll talk about the direction in which they're flowing in a little bit. Trade winds. Trade winds get their names because this was exactly the location in which you go back many, many years ago, even before the United States became the United States. When the ships were out in the ocean, the trade winds were what were helping them to move from location A to location B. So the traders in their big sailboats, in basically their ships, as they were being moved from those locations across the ocean, it was the trade winds that were helping to move them. So again, usually 30 degrees north to the equator or 30 degrees south to the equator. And because they were used by sailors, that's why you get the trade wind name. And again, looking at the equator being located right in this space, talking about the way in which the winds are actually flowing. Again, which we'll talk about in a little bit. Then you have the doldrums. There have been movies that have used the phrase, you know, you've got a case of the Mondays, or you may, that person's in the doldrums. Well, really what the doldrums is a place in which no winds are blowing. Well, the reason why they referred to somebody as having a case of the doldrums was because they weren't doing anything. They didn't feel like they were motivated to do anything, didn't want to do anything. And the reason why the doldrums exist around the equator is because you literally have warm air that's rising to create an area of low pressure. Again, warm air rises because it's less dense. And because all the air around the equator is all less dense because it's constantly being warmed, there is no constant change in temperature of the air as well as change in pressure. So if you don't have a change in temperature, you create no change in pressure. And if there's no change in pressure, they're equal, they're not pushing on one another to create a current of air to cause movement. And that's why the doldrums are usually where winds are not moving, not blowing. And my parents who vacation quite a bit will tell you, the closer you get to the equator, usually the nicer days that you have, warmer days, and very little wind until you get closer to the ocean or to the Gulf, depending on where you go. But if you're inland, on land, a lot of times there's very little wind because it's just warm air and very little change in the actual pressure. Then you get the horse latitudes. The horse latitudes occur around 30 degrees both north and south of the equator. And the The reason why the winds are weak there is that this is a transition phase between that warm, moist air that's coming from the equator moving north and that cool, kind of warming up air mass from the actual poles moving back towards the equator. And what happens is that moisture starts to run out because you have a change in the actual density of the air and the moisture in which it's picking up. And that's why most of the deserts are located here, because of this dry air. Well, the other reason why this got its name, the horse latitudes, has to do with the fact that the horse latitudes were the locations in which boats, as we talked about earlier with trade winds, the trade winds were locations in which sailors would use the winds to move. And as you notice the location, 30 degrees almost north of the equator, both north and south. Well, the horse latitudes got its name because when the winds stopped moving, the sailors and the captains would start basically throwing the horses off the ship, because they were reducing their actual cargo and the mass of their boat. It would allow, hopefully, for them to gain some steam and be a little bit lighter for any wind that they received to cause them to actually move across the oceans. Okay, so that's why you got the name horse latitudes, is because of that. It's the latitudes in which there was very little air movement, and they just simply threw the horses overboard so they could lighten their load. All right, now let me go back here and talk just briefly about these pictures and talking about the direction in which wind moves. You've seen diagrams, as we were going through the notes, that show these particular locations on this global map, showing the direction in which air flows, moving away from the equator or moving towards the equator, depending on the diagram. What I'm going to tell you is you're going to be doing an activity which is called Global Wind Patterns. Global Wind Patterns is going to be found in video E4.p2-29, I believe. And with that, it will explain exactly why the movement of air takes this actual curve and why air is forced in a particular direction. So I'm not going to spend a lot of time right now explaining this, but in the coming videos, you're going to hear more about this and get a much better explanation as to why this occurs, as you see it up here on your diagram. Should you have any questions, let Mr. Fuzak or myself know.